example 2, it says, what is the equation of hyperbola of foci at negative 3, 3, and 5, 3, and vertices at negative 2, 3, and 4, 3? So we start plotting what I know. So my foci are at negative 3, 3, and 5, 3. So 1, 2, 3, 1, 2, 3, that's a focal point. 1, 2, 3, 4, 5, 1, 2, 3, that's a focal point. Again, as you plot stuff on the graph, make sure you're identifying what it is to get a better visual of what's going on. It says vertices are at negative 2, 3, and positive 4, 3. So negative 2, comma 3 is a vertex. Positive 4, comma 3 is a vertex. Looking at the 4 points that I'm given, the vertices and the foci are all positioned horizontally, which makes it a left-right hyperbola. So as soon as I recognize left-right, I know it's going to be x minus h squared over a squared minus y minus k squared over b squared is equal to 1. Plot some stuff and make a decision about the direction in order to figure out which standard form you're going to go with. Once you've established the correct standard form, now our task is to figure out the values of h, k, a, and b. And what I can tell in this problem, since the vertices are horizontal, I need to find the midpoint of the vertices to find the center. So halfway between this vertex and that vertex would be right here. I just count 1, 2, 3 to the right, 1, 2, 3 to the left, so that tells me the center is right there at 1, 3. If the center is 1, 3, what are h and k?
1 and 3.
H is 1, k is 3. All right? H and k are the exact values of what the center coordinates are. H is the x coordinate, k is the y coordinate. Okay, the other things we need to figure out are what are a and b equal to. Hey, looking at the picture, they're given vertices again. So again, the distance from the center to a vertex is either a if you're moving horizontally or b if you're moving vertically. So since we're moving horizontally here, the distance from the center to a vertex, in this case, is equal to a. We're moving 3 left and 3 right, so a is equal to 3. And finally, in the picture, if I'm looking at the picture here, I also have focal points. So I have the capacity to find the focal length in this particular problem. C is always the focal length. C equals focal length. And the relationship between A, B, and C is exactly that C squared is equal to A squared plus B squared. That's the relationship. Remember in the ellipse it was A squared minus B squared or B squared minus A squared. There was a plus sign. This equation has a minus sign, it's plus. So they kind of have similar properties there, but they're different. So make sure you look at the differences, look at the similarities, get those identified. So I know that the focal length is the distance from the center to the focus, so that's 4, so C is equal to 4. And the same here, if I want this one, C is also equal to 4. Again, the center is in the middle, so you should be going the same distance both directions to get to those focal points. So I know that C is equal to 4. I'm going to write that in my list. We don't always have to know what C equals. But in this particular case, since I know what A equals, I don't know what B equals, but I can figure out what C equals by just counting, right? It's easy to find these two numbers. And here's my relationship. C squared, which is going to be 16, because C equals 4, equals A squared, that's 9, because A is equal to 3, plus B squared, we don't know yet. Just take my relationship between A, B, and C, replace A and C with what I know, I can figure out what B is. So if I move the 9 over, I'm going to get 7 equals B squared. So B officially equals the square root of 7. What goes in the formula? B squared. So B squared is 7, right? Even though B is equal to the square root of 7, if you get like 2.65, whatever that, 2.64, somewhere in that general area, and then you square that, like for example, let me show you what I mean. Square root of 7 equals, square root of 7 equals, there we go, 2.65, right? And then you do 2.65 squared, notice it's 7.0225, but But again, b squared equals 7. So 7 is more exact. I wouldn't count it wrong by doing that, but just know that if you're rounding an answer and then use a rounded answer to get something else, it causes a little bit of error. So once I know all this information here, now I'm ready to substitute in everything into there to write the answer. So my correct answer on this problem is going to be parentheses with an x squared over something minus parentheses with a y squared over something equals 1. X minus h is 1, so x minus 1. Y minus k is 3, so y minus 3. A squared, 3 squared is 9, that goes under x. The square root of 7 squared is 7, that goes under y. And there's your answer. Right. So graph what they tell you, figure out the center, figure out either A or B based on a vertex. If you have a slope of an asymptote, that's B over A equals whatever you just figured out, right? To figure out the other. If they give you focal length and focal points and vertices, you'll be able to find A and C or B and C. Use the relationship here to find the other one. And again, once you find all 4 things, substitute into the correct standard form.